In this video, I'm going to answer the question given by the lecturer for the course Microeconomics for Business. This video is going to be used as midterm test. Now, first of all, I have three windows here. The left one, these are the questions. The middle one, the center, these are my answers. The resources for all of my answers are Google Books and AI. So what I do is I search for the related theory regarding each question and I try to summarize. Now for the right one, I have Mikro, which I'm going to use as a whiteboard. Now let's get into the first question. First question, Kevin is a basketball coach. He evaluates his players based on three criteria, which are height, strength, and speed. Kevin prefers one player over another if he is better in at least two of these criteria. Assume that there are no players with the exact same height, nor the exact same strength, nor the exact same speed. 1a. Are Kevin's preference complete? What complete preference is? 1b. Are Kevin's preference transitive? What is a transitive preference? Okay, so for 1a, are Kevin's preference complete? The answer is yes, Kevin's preference are complete. What is a complete preference? A complete preference in macroeconomics is an assumption made for analytical purpose where it refers to rank all possible bundles of goods and services. Now I'm going to write down here. Okay, complete preference. Now, in complete preference, the consumers could say that either there are three things. Okay, either A is preferred to B, or B is preferred to A, or they are indifferent, meaning that A equal to B. So if the question given is included in one of these, then it means it is a complete preference. So how am I going to prove it? Now let's write down Kevin. How he going to choose? He going to choose if the player is better than my writings in at least two criteria. Those are how Kevin will choose the player. Now, what is the assumption here? The assumption here we could see in the question, each player, they don't have exact same height, no exact same strength, no speed. So it means that, okay, let's write that down first. The assumption, the height is not equal to strength, not equal to speed for each player. Now for 1a, I'm going to assume there are player A and player B, and then we have the criteria, the height, the strength, the speed. I'm going to assign points in each of these. For A, going to be like this, and for B, because remember the assumption is the height for each player, height, speed, and strength. Height, strength, and speed are not equal. I would assign it like this for B. 3 for height, and then 1 for strength, and 2 for speed. Now, Kevin going to choose if the player is better at least in two criteria. In this assumption, in terms of strength, A is better than B. In terms of speed, A is also better than B. Now, it means Kevin going to choose player A. Okay. Does this assumption included in any one of these? The answer is yes, it is included in A is better than B. So that's the answer for 1A. It is a complete preference. Now, we go to 1b. Are Kevin's preference transitive? What transitive preference is? So, a transitive preference, let me write it down. Transitive preference. In transitive preference, they have an assumption. It has an assumption where if there are three options, A, B, and C, it is stated that if A is better than B, B better than C, then it means A is better than C. So let me write it down. If A is better than B, B better than C, automatically means that A is better than C. Now, for 1B, I'm going to add another player here because transitive preference include three objects, player C, and again the assumption none of each player have the exact same height, speed, or strength. Then I'm going to assign 2 here, 3 here, and 1 right here. Now, if you take a look at this, the difference is that the difference between 1A and 1B is now we have another player, and because we have another player in this assumption, we can't say it like before. If A is better than C, better than B, I mean, based on the assumption that if the player better at least in 2 criteria. And why is that? Why that doesn't apply in 1B? It doesn't apply because we have an additional player of player C. Based on this one, how Kevin going to choose with the assumption that no players have equal height, strength, or speed, then it means there will be no A better than B or B better than C or A better than C. And the reason for that is because again, Kevin going to choose the player if it's better than at least 2 criteria. If there is player C, additional player C, it means then for each one of these, A, B, or C, there will be no players that are better than one another. So in this case, we can say A is better than B or B better than C, because each one of these don't have at least 2 criteria where they are better over the other players. So that's why 1B is not a transitive preference. Well, pardon me if my explanation is a bit confusing at first. Anyway, let's get to question number 2. Ani and Budi are utility maximizing consumers. Given the income and market prices, Ani choose a bundle that gives her a utility of 100, while Budi choose a bundle that gives him a utility of 110. 2a. What is utility? How does utility explain the level of happiness? 2b. Is Budi happier than Ani? Why? For 2a, this one is number 1. So we go to number 2. Number 2a. What is utility? How does utility explain the level of happiness? Utility in economics refers to the satisfaction a consumer gets from consuming goods or services. Well, it simply means we trade our money given the market prices for the goods or services, whatever that goods or services are, where we will consume those goods or services to fulfill our satisfaction, which could mean our happiness. But if I were to try to describe it, happiness, your total happiness is the stack of each utility you make. So utility is a part of your happiness. And if I were to give it an example, so there are utility when you consume food, utility when you, let's say, go to a movie, utility when you go to the gym, trade your money for going to the gym. Now all of this, you add all of this, and that is your happiness. So that's what I meant by how utility is related to happiness. And 2b, its Buddhi is happier than Ani. What is the reason? Now, Buddhi is not happier than Ani because utility is an ordinal concept, so we can't tell who is happier. Again, in utility is a subjective concept, meaning, and this is the important point, it varies from person to person. And why it varies? Because here we have utility for Ani is 100, utility for Buddhi is 110. If we are going to think logically how we get these numbers, of course we're going to consider the several factors like Ani budget, also Buddhi budget. So if in the first place Buddhi got way more budget, a higher budget than Ani, then it means, of course, the result of the utility of Buddhi would be higher than Ani. But again, if you take a look at the question are Ani and Buddhi are utility maximizing consumers. It means that we don't have to know about Ani budget or Buddhi budget. What we knew is that both of them are maximizing their utility. So the utility of Ani 100 here is Ani maximized utility, and Buddhi is maximized utility 110. So it means both are equally happy given their own budget. Then I conclude, no, Buddhi is not happier than Ani because both of them are maximizing their utility, even though the nominal for the utility is different. Ani 100, Buddhi 110, and as I tried to explain before, those numbers comes up from different factors like how much budget Ani has or how much budget Buddhi has. If in the first place Buddhi has a more budget, means, well, of course his maximized utility is higher. But anyway, they are both maximizing utility, so both are Buddhi are not happier than Ani, or Ani is happier than Buddhi. Both are maximizing utility. Now let's go to number 3. Question for number 3. Udin consumes only iced coffee, symbolized with X, and nasi goreng, symbolized by Y. Suppose that his preference can be represented by utility equals min xy. So iced coffee and nasi goreng are perfect complements. Udin wants to drink one iced coffee for every nasi goreng he eats. 3a. Please explain what is a perfect complement. 3b. If the price of iced coffee increase, Udin's demand for both coffee and nasi goreng will decrease. Does it represent the substitution effect? Now we go to number 3a. Number 3a. Number 3a. Okay. For number 3a, what is a perfect complement? A perfect complement in economic are goods that are consumed together in a fixed ratio, where the demand for one good is directly tied to the demand for its perfect complement. So in this question, we have X as iced coffee and Y as nasi goreng. Fixed ratio mean you will consume one iced coffee for every one nasi goreng. Oh, wait a minute, it's not Y but 1. For one nasi goreng, or the other way, one nasi goreng for every one iced coffee. And the demand, it is stated, the demand for a perfect complement goods are directly tied to its perfect complement. So it would means, if let's say you consume 0 iced coffee, means that you will consume 0 nasi goreng. Why is this? Because it is a perfect complement. So that's what's a perfect complement is. Now if let's say you want to consume like 2 iced coffee, 2 eggs, then it means you will also consume 2 nasi goreng. So that's what a perfect complement is. In this case, I explain like if the demand decrease or the demand increase. So if the demand for eggs increase by 1, then it would means Y also increase by 1. If it's decreased by 1, it is also Y also going to decrease by 1. So that's what is a perfect complement. Now we go to 3b. 3b question is, if the price of iced coffee increase, Udin's demand for both coffee and nasi goreng will decrease. Does it present the substitution effect? The answer is no, it doesn't represent the substitution effect. Now the first reason, because first of all, we know that it is a perfect complement goods. It is a perfect complement. Because it is a perfect complement, as I have defined it in 3a, if the demand for, okay, what's happened here is iced coffee price is increasing, right? The price for iced coffee increase, meaning the demand for iced coffee would also decrease. And because the demand for iced coffee decrease, then the demand for nasi goreng also decrease. And why is that? Because they are a perfect complement, as I had defined in 3a. Now we now clearly know for 3b it is not a substitution effect, rather the demand is caused by, because both goods are perfect complements. Now let me explain what is the substitution effect. What will happen if it were the substitution effect? Now disregard about perfect complement first. Let's say the same one, we have iced coffee we have nasi goreng, and they are not perfect complements. They are not perfect complements. What will happen with the substitution effect is, if the price of iced coffee increase, then of course, with the general rule of demand and supply theory, the demand for iced coffee would also decrease, because the price is rising, right? The demand will decrease. Now, if it were the substitution effect, the demand of nasi goreng would not decrease. It will not decrease. And the reason for that, because again, it is the substitution effect. If the price of coffee increase, well, Udin could change it to substitute that goods into maybe iced tea or maybe iced boba. He could change it. He could substitute the good. So if it were the substitution effect, if the price of iced coffee increase, the demand for nasi goreng will just stay the same. It will not affect the demand for nasi goreng. But in this question, well, 3B, no, it's not a substitution. It's not due to substitution effect, because the decrease of iced coffee, the decrease demand of iced coffee and nasi goreng is affected by the fact that they are a perfect complement goods. That's for number 3. Okay. Number 4. Suppose potatoes are a given good. Please explain. For A, please explain what a given good. For B, when the price of potatoes increase, does both the substitution and the income effects cause the demand for potatoes to increase? So, for A, number 4, what is a given good? A given good in economic is characterized with a good where the demand will increase if the price of a given good increase. So let's symbolize potatoes here with X. So a given good where the price of X increase, then the demand for X would also increase. This is the characteristic of a given good. If you are smart enough to realize this contrary to the general rule of the demand of a good, where it is stated if the price increase, then the demand will decrease. But this is not the case for a given good. In a given good, when the price increase, the demand also increase. And the reason why this happened is because a given good, they have no close substitute. So consumers regard this good, in this case potato, as something that they must have, like it or not. So the good here, potato, a given good, is such a vital thing in their life. So that's why when the price increase, the demand will also increase. That is the reason. Now we go to 4B. When the price of potatoes increase, does both the substitute and the income effect cause the demand for potatoes to increase? Okay, first one, the substitution effect. The answer is no. The substitution effect, it will not cause the demand for a given good increase, or even we're going further, it's not going to decrease the demand for any given good. The reason for that is because, again, as I explained before, a given good, it doesn't have no close substitute. So of course then substitution effect would not apply. Now for the second one, the income effect. Does the income effect cause the demand for a given good, in this case potato, to increase? The answer is yes. Why income effect cause the demand to increase? The reason for that is because, first of all, given good has no substitute, and as I explained, consumer they must prioritize to buy this given good, because this given good is such a vital thing in their life. So whether the price increase or even the price decrease, they should prioritize buying this given good. Then after that, after they already fulfill their quota for the given good, then they would buy other things outside the given good. So consumer will, given their income, the change in their purchasing power, they will always prioritize buying the given good. So that's why the income effect cause increase in potato demand. Number 5, a production function use capital and labor as inputs. 5a, what is a production function? 5b, what is diminishing marginal returns? 5c, what is increasing return to scale? And 5d, if both capital and labor have diminishing marginal returns, does the production function display increasing return to scale? Please explain. So we go to number 5, 5a. What is a production function? A production function in economics expresses the relationship between the amount of inputs used to produce the amount of output produced. So how many eggs of inputs will produce how much output? The relationship between these two is called the production function. Now we go to 5b. 5b, what is diminishing marginal returns? The diminishing marginal return stated that at some point, if we were to add an additional factor of production, meaning input, the increase in additional output would be lower than before. Let me give an example. Let's say an input. We have input here 1, 2, 3, 4, and then the amount it produced with this given input. I will give a random number. Now I'm going to write down the marginal output. So for input 1, you give 1 input, it will produce 2, so the marginal will be 2, right? Now for input 2, it will produce 3, so there is an increase of plus 3 here, the marginal will be 3. For input 3, produce 9, here there is a plus of 4. So the marginal would be 4. And here, from input 3 to input 4, the plus becomes only 2. So the marginal would be 2. So input 1, before input 1, we know there is 0 input, like you do nothing. So input 1 purchase 2, the marginal would be 2. And then input 2, the margin will be 3, because 5 minus 2. And then input 3, 9 minus 5 equals 4. And then in input 4, this is where the diminishing marginal returns begin. Why? Because again, as I defined it before, if we were to add additional output here, each of this plus by 1 plus 1 plus 1, at a certain point, the increase in additional output here, what it produced, how much it produced, would actually decrease, and the diminishing marginal returns happen in here, where the increase in inputs only produce additionally 2 goods, which lower than before, which lower than 4 or lower than 3. It is lower than before. So this is where the diminishing marginal return happen. So that's for number B. 5C. What is increasing return to scale? Increasing return to scale is a part of return to scale in economic. It is a concept, whereas we know the other two being the constant return to scale and the decreasing return to scale. Increasing return to scale happens when output increase by a greater proportion than inputs. So let me write that down. 5C. We have the constant return to scale, decreasing return to scale, and increasing return to scale. If it's increasing, if you put 1 input, then the output would be 2x of that, a greater proportion. If constant, if you put 1 input, then it means the output will also increase by 1. If it's decreasing, it means if you put x input, it will be lower than 1. So that's what an increasing return to scale is. It happens when the amount of output increase by a greater proportion than your inputs. That's an increasing return to scale. Now we go to D, 5D. If both capital and labor have diminishing marginal returns, does the production function display increasing return to scale? If both capital and labor have diminishing marginal returns, the production display would not display increasing return to scale, because the reason for that is the addition of capital and labor, when it diminishing, would result in a decrease in output. So the reason why it's not displaying an IRTS is because it is diminishing. So the amount of input will be lower because it is diminishing. Therefore, we could not say that it is an increased return to scale. That's for 5D. Now we go to 6C. The marginal rate of substitution, MRS, at an arbitrary bundle xy is minus 2xy divided by x squared. How comes? So (6c). We want to prove y is the MRS equals to minus 2xy divided by x squared. How do we prove this one? First of all, we must know that MRS always negative. It's always negative. And the formula for MRS is marginal utility of good x divided by marginal utility of good y. This could be elaborated again into du xy per the dx, and then divided by my could be elaborated with du xy divided with dy. So what is d here? D here means derivative. Let's start with finding the mux from the equation of utility function, which we know from number 6a. The utility function here present her preference is u equals x squared times y. X squared times y. So what's the mux? The mux is the derivative of x in equation of y. Then it means this one will goes down, become 2x times y. So 2x times y, or 2xy, is mux. Now what's the muy? Same again, from the equation of utility function, x squared times y. In this case, a y without number means it is 1. Then you put that down here, becomes x squared times 1, and because 1 minus by 1 becomes 0, the y is gone. Therefore we only got x squared for muy. Now that we know the mux and muy, we now know that the MRS equals to 2xy divided with x squared. Don't forget to put minus to it. Why? Because MRS is always negative. So that's how we prove the MRS with equation. Now we go to 60 right here. The question for 60 is explain why MRS should equal to MRT, which comes up with y equals px times x per 2 times by. Well, essentially, MRS is the rate in which consumer willing to give up good x for additional unit of good y. Well, MRT defines how much a supplier is willing to give up producing good X for additional unit of good Y. The reason why MRT should equal to MRS simply because MRS is regarding consumer. How they are willing to give up on food X for additional food Y, whereas MRT is in regards of producer. Whereas how much of good X willing to give up for good X for additional good Y. So the reason why MRT must equal is because we want producer to consumer to intersect with each other, having its equilibrium. So that's the reason why MRS equals MRT. MRT equals MRS. That's the reason. So we want the producer and consumer meet its equilibrium, both of them. Now I skip 6E, get straight to 6F. The question is, the price elasticity of the demand for book is derivative X. Is that derivative X times BX, this one right here, equals to -1. What does -1 mean? A -1 means that it is a price elasticity. Demand for books implies it has unitary elasticity. The negative sign indicates -1. Okay, elasticity. Demand for books implies it has unitary elasticity. Negative sign here indicates if the price of books increase, then the demand for books will decrease, and vice versa. Meanwhile, the value 1 here, indicate the change of percentage quantity demanded for books is equal to the percentage change in price. That's what it means. Let's go to G, 6G. 6G. The question is, the cross price elasticity of the demand for books with respect to the price of video games is this one, equals to 0. What does it mean? If it's equals to 0, it means that books and video games are independent from each other, meaning the change of books, which symbolized with X, will not impact the quantity. The demand in X of books will not impact the quantity of the demand for video games. So that's what it means with equals to 0. That's for number 6. Now I skip H, I, J, K, and L. Well, honestly, in the first place, number 6 is kinda, for me, it's quite challenging. It's quite a hard questions to answer and understand. So I'm going to straight for number 7. Number 7, we got 5 questions, A to E. For number 7, I only answered 7A and 7B. For 7a, well, A and B is asking the marginal product of labor and then marginal product of capital. So I would want to write down the function of F first. F labor capital equals to L squared times K to the power of 1.5, not 1.5, a half. Now for 7a, we will ask why the MPL equals to 2L K to the power of half. Why is this? Well, MPL is the derivative of L in the equation of F. Then we would get, here is the function of F. The derivative of L would be, this one goes down, 2L, it becomes 2L times K half to the power of half. So there we have it, 2LK to the power of half. So that's for 7a, that's where the MPL comes from. Now for B, it is the same. For question number B, it is asking about the MPK. The formula is the same. The derivative function LK dF per dk. The derivative of k in function f, we're going to write down the function first. And then this goes down. Minus, it means that it will be minus by 1. It becomes L squared half times K minus to the power of minus a half. So it becomes 1 by 2 L squared K minus to the power of minus 1 by 2. So there you have it for 7a and b, asking about MPL and MPK. Why MPL equals 2LK to the power of a half, and why MPK equals half L squared K to the power of minus 1 by 2. So that's it. So that's for my midterm test. Thank you for listening.